So, okay, guys, this is Madhav again, and now we are going to discuss about quicksort. So, quicksort is nothing but it is just depends upon this one of its binary condition, that is root nodes left must be less than that of the root node, and root nodes right must be greater than that of the root node. But here it is just using that condition for the purpose of pivot. So what is meant by pivot, I will just tell those things later. So now I'm going to just show you the basic definition of an uh, quicksort. So quicksort is a divide and conquer algorithm. It works by selecting a pivot element from the array and partitioning the other elements into two subarrays according to whether they are less than or greater than the pivot. So let me just open my paint. So here we can just see. So now basically the main thing of this quicksort is to just give a clarity, like now this will be a pivot element. The element, the pivot element will only be one. So the elements which are to its left side must be less than pivot, and here it must be greater than pivot. So this is the an order. So it need to follow this basic thing to just satisfy the conditions. So now after this, after satisfying this, we will just get an order, like if there are set of elements, then for suppose let us just take like 5, 2, 7, 9, 12. So if we are taking the element 5, uh, and we need to just take some more elements, 2, 3. So now if we just see this, if we just take the element 5 as a pivot, then after quicksort the array should look like this. So 5 should be at center. So now 2 comma 2 comma 3, and then 5, and then 7, 9, and 12. So after the quicksort function gets executed, so this should be the order of the elements. So the smaller element should be towards its left side of the pivot, and the bigger element should be towards its right side. So this needs to be followed to just satisfy this condition. So now let us just implement this quicksort algorithm with some values. They are 7, 6, 10, 5, 9, 2, 1, 15, 7. So these are the set of values. So with this set of values, we are going to just perform quicksort with these things. Yeah, now we need to just remember one thing, that is this should be start. So this thing must be start. So 1 minute. So yeah, this must be start, and this must be end. So basically these are the two things which we need to just use for our array representation. So but the only thing is start need to just increment, but end need to just decrement. So these are the conditions which we need to just remember. I will just explain this because start need to just move on from front till the last node, so that it will just check its element with its next node. If it is greater than, if it is less than the pivot node, then it will just stay there. So if it is less than the pivot node, then it will just stay there. And then the end will just decrement. If it is greater than pivot node, then it will just stay there. So after that, we will just do a simple swapping so that the pivot node gets changed. So the pivot nodes changes will just start slowly. So this is the basic condition. So we will just discuss in upcoming steps so that you can just get some clarity. So now start should start from 0. So we need to just check the elements, like greater than A of start. So the elements greater than A of start. So the start position need to go there and stop. So let me just write this loop again. Array again. So 5, 9, 2, 1, 15, 7. So it need to just be in this order. So again, now the start will just move from here and then it will just reach a position where it is greater than the A of start. So here it is greater than A of start, that is. So now the start will just end at the position at 10 because it is greater than 7. So now the start will just stay here. So this is start now. STA. So yeah, this is start. So now end should decrement from back to front. That is from 7 to less than or equal to the pivot. So basically now I had just forgotten to return note down this pivot element. So now pivot element is 7. Now we are taking the starting element as a pivot element. So less than or equal to pivot element. So end's first position is 7. 7 is less than or equal to 7. As it is true, start will just stay here itself. End will just stay here itself. So now a simple swapping will take place with this. So now this element will just move here and then this will be with this. After swapping, the order will be like this: 7, 6, 7, 5, 9, 2, 1, 15, 10. So it will be in this order. The pivot element will not change, but the start position will be in its third position. So this is start. And then the last position is end. So it will also just stay there. So now again, we need to just check this condition again. So the elements which are greater than the pivot is 7, which is remains the same. So greater than 7, 7 is not greater than 7, so increment. 5 is not greater than 7, so increment. 9 is greater than 7, so start will stop at 9. So 7, 6, 7, 5, 9, 2, 1, 15, and then 10. So start will just stop at 9. So start will just stop at 9 and then and less than or equal to pivot. So 10 is not less than or equal to pivot. So decrement. 15 is not less than or equal to 7. So decrement. 1 is less than or equal to 7 is true. So end value will be here. So the end value will be here, and now we are going to just perform a very basic swapping, that is for 9 and 1. And then now the array will be like this: 7, 6, 7, 5, 1, 2, 9, 15, 10. So now the array will just look like this, but start position will be here: 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The fifth element is this, and the start position will just remain here, and the end position will be 5, 6, 7. So the end position will remain here. So the end position will just remain here. Now again, we are just going to just check this condition as 1 is not greater than 7 increment, 2 is not greater than 7 increment, 9 is greater than 7. So start will just stay 9. So 7, 6, 7, 5, 1, 2, 9, 15, and then 10. So start will just stay at 9. So 9 will be just containing the start, and then end will just decrement less than or equal to pivot. So 9 is not less than or equal to pivot decrement. 2 is less than or equal to pivot, that is true. So Now this will just become the end. As now we can just make a normal swap, but this is not true if end is greater than start. Sorry, end is less than start. So end should be at its top position and start should be a little bit less, as the condition is just violating. So we need to just remember one thing. So the first position of this node must be replaced with the value of end only in the case of this end less than start. So now the value will, the array list will just look like this. So let me just represent this thing. So 7 should be sorted with 2 and then 2 should be with 7. And then now 2, 6, 7, 5, 1, 7, 9, 15, and then 10. So this will be the sorted list of array. Now, if we can just see here, so this will, we need to just remember this thing, less than or equal to pivot and greater than pivot. So now if we can just see this in the form of array. So now we had just discussed the pivot element as 7. So 7 will be in its center position, that is 7 is here. And then, so this is, these values are less than or equal to pivot. So these values are less than or equal to pivot. And then these values are greater than or greater than pivot, not equal to, only greater than pivot. So basically, this is the basic fundamental theory of this quick sort. So we need to just perform as well for this 2, 6, 7, 5, 1 and 9, 15, 10 by taking 2 as a pivot and 9 as a pivot, and then just performing this same method again and again till we just get this sorted data. So this just work on divide and conquer principle as we have just discussed in this definition. So this is the basic fundamental for quicksort. Thank you for watching.